looking to solve this oblique triangle, and I'm going to notice that I have an angle, one angle only. It's opposite side, and that means this one is adjacent to my angle. So this is the dreaded ambiguous case side-side angle. Or if you're like some kid in my high school geometry class, angle side-side, but we're going to go with side-side angle. And this is the ambiguous case. There are several ways it could turn out depending on how all these things relate to each other. So the first thing we need to do is figure out what are we looking for. In the ambiguous case, I might have one triangle, I might have none at all, or I might have two. So we're going to figure out where are we? What are we looking for? I'm going to start, here's my angle, 35 degrees. I'm not getting out the protractor or anything, but I know 35 degrees is acute. That's angle A. The adjacent side, little b, is 12. And now I have to put in the opposite side. Well, let's see. My opposite side is 17. The question is, can I fit it more than one way and make a triangle? And the answer is, if its length is 17, if I try to fit it going this direction towards angle A, it's going to have to be less than 12 in order to fit in there. And it's not. It's more than 12. It's 17. So there's only one way that this side of length 17 is going to fit. That's going away from angle A. So in this case, I'm going to get one triangle from this information. This is angle B down here, which means we have C up at the top. Anytime the opposite side is longer than the adjacent side to the given angle, I'm going to get one triangle only. So I need to find all the information just for one triangle. I'm going to notice my starting point here. I have angle A and side A. So that's going to be my starting point for my law of sines. Got the sine of angle A over side A. And there's really only one way to go here. I only have one angle. So I'm going to have to use the given side and its opposite angle. That's the sine of angle B, which I don't know, over 12. Well, little equation. So I'm going to multiply both sides by 12. And that's the sine of angle B, which is nice, except for I don't want the sine of angle B. I want the measure of angle B. It's an equation. How do we solve equations? We use inverse operations. I have sine B. I want B. I'm going to have to use the inverse of the sine function. And if I do that on the right, I'm going to have to do it on the left also. On the right now, I have the arcsine of the sine of B. B is an acute angle in a triangle. So there's no issue with domains and ranges, anything like that. The arcsine of the sine of B is just angle B, which is exactly what I want. On the left, you can put this all in the calculator pretty much in a row. Be careful with parentheses. And we should end up with a measure of angle B of 23.54 degrees. I'm going to write down 23.54 degrees, but I'm going to keep all the decimal places that my calculator gives me. I don't want to have round off error by rounding off in the middle of the problem. So I'm going to keep all the decimal places either by leaving it on my calculator and going back to it, copying and pasting, or by storing and later recalling. If you're low tech, you can write down all the decimal places and type them all back in later. There's different ways to go about it. In any case, we want all the decimal places for future calculations. Okay, great. We have angle B, which means now it's going to be real quick to find angle C. We can do it by subtraction now that we have two angles. Let's see, so 180 minus the two we have. 35 and 23.54. The measure of angle C is 121.46 degrees. And again, with all the rest of the decimal places. One more thing to do, and that is we need to find side C. And the way that we're going to be able to do it is by using the law of sines again. This time I don't really have a choice. I'm going to have to use the value of angle C that I just calculated. I'm going to have my sine 35 over 17. That's the A, sine of A over A equals the sine of, and again, I'm writing down 121.46 degrees, but I'm going to use in the calculation all the decimal places. Over, I don't know. That's what we're looking for. So I'm going to multiply by 17, multiply by C, and then we'll divide by the sine of 35. So my expression for C all the other decimal places, and calculator to the rescue. I'm going to get a length of angle C of 25.28. Did I just say a length of angle C? A length of side C. Angle C is an obtuse angle. It's the longest angle. I'm having trouble with words today. Angle C is the biggest angle, so it's going to be opposite the longest side. And that calculation we just found for side C is 25. That's our longest side, so that's a good sign. And we have solved this triangle.